Hey boys and girls, so today we're going over Unit 6, Lesson 5, which is mix of all quadrilaterals. Before we get started, like always, put your name at the top and then we're going to jump on in. So today I worked out the do now in advance. You guys can absolutely use your notes as a reference. We have a lot of work to get through in this lesson and I didn't want the video to be super long. So I only worked out the do now first just so that we could save some time here. So as we read the do now, it says, question 1, quadrilateral MATH has both pairs of opposite sides congruent and parallel. As soon as you see this, immediately I can say that it's going to be a parallelogram. We learned that there are 5 different ways to show if I'm looking at a parallelogram or not. This was one of those methods, okay? So if I know it's a parallelogram, that's going to help me answer the question. Which statement about quadrilateral MATH is always true? So I'm going to highlight always with you because this is the key word that you want to look for, all right? As I look at the first choice, line segment MT is congruent to line segment AH. So that would have been the diagonals. They're not always going to be congruent to each other. I guess it could happen, but usually in a parallelogram, that's not true, okay? And I wanna know something that's always true. This is definitely not always true, so I gotta look at choice 2. Line segment MT is perpendicular to line segment AH. Again, that is not always true in a parallelogram. I know that the diagonals are perpendicular, right, that symbol. They're perpendicular in a rhombus, they're perpendicular in a square, but it's not always gonna be perpendicular in a parallelogram, all right? So it's not gonna be choice 2 either. So that means it's 3 or 4. It's gonna be choice 4 because I know that the letter in the middle is the vertex. It's the most important letter. So when I highlighted out angle MAT and angle MHT, I saw that those angles were opposite angles, and I know that opposite angles are congruent in a parallelogram. That's a property. So I know this will always be true, no matter what the angle measure is, the side lengths are, right? That's always gonna be true. So number 1 was choice 4. Number 2, a parallelogram must be a rhombus when, so again, a rhombus has all the properties of a parallelogram, but what makes it a rhombus and not just a parallelogram is these 3 extra bullets I wrote out on the side. Okay, I just sketched a quick picture here of a rhombus just to give you an idea of each one. So I know all sides are congruent, so I dashed out all 4 sides. The diagonals bisect the angles. So I know that opposite angles are equal, but each little piece will now be equal as well because they're being bisected. That means they're being divided into 2 equal angles. Same thing, these opposite angles are equal, but they're also being bisected. Again, I have 2 equal pieces up top, 2 equal angles down below as well. And last but not least, diagonals are perpendicular. That was just the symbol I wanted to add on for practice. Perpendicular means they form 90-degree angles right in the center where those diagonals are crossing. All right, so when I look at the answer choices, choice 1, diagonals are perpendicular. That always is true in a rhombus. So it would have been choice 1. If I look at choice 2, the diagonals are congruent. That's in a rectangle. Rectangle and rhombus are not related, so totally separate. Choice 3, opposite sides are parallel. Opposite sides are parallel in a parallelogram. All right, so that's not enough to then make it a rhombus. And then choice 4, opposite sides are congruent. Again, that's true in a parallelogram. That's not enough to make it a rhombus. One of these makes it a rhombus. All right, so that was number 2. Let's jump into the bottom here. It says, if the lengths of the diagonals of a rhombus are 10 and 24 meters. I'm immediately going to stop because it looks like they gave me a sketch of a rhombus. And if I'm talking about the diagonals of a rhombus, I don't see those drawn in, so I'm going to add those immediately. So here I go. With my straight edge, with my ruler here, I'm gonna draw in both diagonals. I want this to look nice and neat, so it's easy for me to look back and study from. So now that I have those diagonals, I know that this entire piece is gonna be 10 meters, and this entire piece is 24 meters. But it's being like broken up here into 2 sections, again, 2 sections. So if you remember back, I know that a rhombus has all the properties of a parallelogram. Well, I know in a parallelogram, the diagonals bisect each other. So I know that this chunk equals this chunk, and the same thing, this top piece equals this bottom piece. So I'm not gonna use the number 10, I immediately wanna cut 10 in half, and I wanna make it 5 and 5. Same thing, I don't wanna use 24, that's the whole piece, it's being broken up. So half of 24 is 12 and 12. And again, I can show that work up top, half of 10 is 5, Half of 24 is 12 again. So that's where I'm getting those numbers from. All right, so now that I use this first piece of information, I'm going to continue reading. Anytime you get to the question, I always underline it. So when I'm done solving, I can look back and make sure that I answered the question completely. I want to determine the length of one side in meters of the rhombus. Well, I just said up top here that I know that all sides are congruent in a rhombus. So I'm going to dash that out at the bottom as well. So I know this equals this, which equals this, which equals this. All right, the only, what's the right word here? So the only issue, I should say, with me using one dash on all these sides is that I already am saying that one dash represents 5 meters. And I also said that 2 dashes represents 12 meters. So really I'd have to put at least 3 dashes or more to show that these would have a different length. I have no idea if these will be 5. I don't know if they'll be 12. So for right now, I have to use a different number of dashes. Those are also known as tick marks. All right. So if this is what I'm looking for, and I know all of them are the same, I'm just going to put an X on one of those sides. I could add an X everywhere, but that might confuse me. If I'm only looking for the length of one side, I'm just going to add one X to remind myself that this is what I'm looking for, just one side here. All right. If you again remember the property, I know that the diagonals are perpendicular to each other. That means they form right angles right at the center. So I already used the fact that all sides are congruent. Knowing that the diagonals bisect the angles, I don't need, because I'm not looking at angle measure in this question, so I can skip this bullet, and I definitely need to use the third bullet down below. So I'm gonna just quickly mark out those 90-degree angles everywhere. So now when I look back, if I'm looking for this missing side of a right triangle, we had gone over that we're going to use Pythagorean theorem to do that. So I'm just going to highlight out this one right triangle. You guys know us. We love to highlight, so I'm just going to do that on the side. Okay. Pythagorean theorem is a squared plus b squared equals c squared. I know that c represents the hypotenuse, and the hypotenuse is right across from the right angle. So I know that c is going to be represented by the variable x. So I'm going to have x squared. And I know that a and b have to be the 12 and the 5. So in parentheses, I have 12 squared plus 5 squared equals x squared. All right, I'm going to solve this through. 12 squared, 12 times 12, it's 144. 5 squared is 25. And that equals x squared. When I add those together, I get 169 equals x squared. Now I have to get rid of the exponent too. The opposite of squaring is square rooting. So I'm going to take the square root of both sides. That gets rid of the 2. The square root of 169 is 13. Comes out to a really nice number. So determine the length of one side in meters. One side would be 13 meters long. All right. Cool. Bottom, joke of the day. Why was your best friend late to first period geometry class? Yeah, you guys got it. He got on the wrong bus. Get it? Rhombus, wrong bus. Okay, great. Let's go to the next page. All right, here we go. In rhombus, T-I-G-E, diagonals T-G and I-E intersect at R. I can see they are intersecting at R. The perimeter means to add all sides. The perimeter of T-I-G-E is 68 and T-G is 16. Determine the length of diagonal IG. So just like I've already done, you always want to highlight out everything that's important. You always want to underline the question. Okay, here we go. What do I know about perimeter in a rhombus? Well, perimeter means to add all the sides. So really I need to ask myself, what do I know about all the sides in a rhombus? Yeah, all of the sides are equal. So I'm going to mark that with little dashes, right? 1, 1, 1, 1. It's the same amount of dashes to show that it's going to be the same number on each side. They're equal. So if I know when I add up all of these sides, I get the number 68, well, I'm going to take 68 and divide it by each side, right? 68 divided by 4, because I want to see how long each side would be. Each, I have to divide. 68 divided by 4 is 17. So I know that the length of each side is 17. I'm going to fill that in. 17, 17, 17, 17. Boom. I use the 68. Good. Next, TG is 16. TG, that's the whole segment. I can't really use 16 on the whole thing because it's being broken up here into like chunks. But I know those chunks are going to be equal because we just went over it on the first page. So I know that TR is going to equal RG. I know this because a rhombus has all the properties of a parallelogram. In a parallelogram, diagonals bisect. That really means they cut each other in half. So I know that this top piece should equal the bottom piece. I also know that IR will be the same distance as RE, all right? But they didn't give me any information on this diagonal, so I'm just gonna leave it alone. All right, so again, if I know that TG is 16, that means if I divide it by 2, each piece is going to be 8. So I'm gonna mark an 8 at the top and an 8 at the bottom here. And then again, the question, determine the length of diagonal IE. All right, so here's diagonal IE. So it turns out that this is actually the piece that I want to find, that whole chunk. But we just went over that I don't know how long the whole chunk will be, but I can figure out how long each piece will be. So it turns out that I actually am going to mark that extra diagonal with 3 dashes up top and 3 dashes down below. All right, because right now I don't know how long it is. So I don't want to use 2 because that would mean this is 8. And I don't want to use 1 because that would mean it's 17. I got to use a different number here. We just went over on the first page that in a rhombus, when you're talking about the diagonals, they are perpendicular lines, right? They form those 90-degree angles, so I'm going to add that on as well. And then again, I know that if those are 90-degree angles, that means each one of these shapes is really a right triangle now. All right, so I'm just going to highlight out one right triangle. Because anytime I'm dealing with a rhombus, 99% of the time, I want to think right triangles, all right? Because that's the purpose of these rhombus questions. You only really need to remember that the perpendicular lines are in the middle, right? They form 90. So that means that I don't just have 4 triangles that make up a rhombus. I now have 4 right triangles that make up a rhombus. When I'm looking for the missing side of a right triangle, we use Pythagorean theorem. So that's what I'm going to do here. I know is the hypotenuse. So if I draw a little arrow here, that means 17 is the hypotenuse. So when I write the Pythagorean theorem, a squared plus b squared equals c squared, I know that 17 will be plugged in for c because that's my hypotenuse, and I'm going to put it in parentheses. You always want to look for the hypotenuse first, just like I did on the first page, because now that this is out of the way, that means the side I don't know, an 8, have to be my a and b. So I'm just going to call this a, just so it fills in with my formula here. So I'm going to have a squared plus 8 squared equals 17 squared. All right, so here we go. A squared plus 64 equals 289. You can just plug these right into a calculator to get these numbers. And now just like Algebra 1, if I want to get a by itself, I got to move that 64 to the opposite side by doing the opposite operation. So when I subtract 64 over, these cancel. So now I have a squared equals 225. In order for me to get rid of the square, I have to take the square root. So that gets rid of the exponent 2. This is a perfect square. A is going to be 15. So I'm going to fill that in here. I know that it's 15 up top, and it's going to be 15 down below. Because these were bisected, they are evenly being split up. All right. So if I want to reread the question now, determine the length of IE, that whole segment. Well, I all the way to E, I know that the top chunk is 15, the bottom chunk is 15. So 15 plus 15 is 30. So I'm going to fill that in. IE, 15 plus 15 gets me 30. So that would be my answer for this question. All right. I want you guys to try the next one on your own and then check back in a minute for that answer. So at this All right, so as we look at the next question, I drew a rhombus to help myself out here. It's very similar to the questions that we've been working on. Anytime you see diagonals, you should be thinking forming perpendicular lines, right? That also gets you the right triangle, okay? So again, if I know that this diagonal is 12 long, half of 12 is 6, that means each piece is 6. Half of 16 is 8, so that means each piece is 8. Okay, something important when you are labeling, it has to go in order. So it doesn't matter where you were put V to start. I put it in the top left. You could have put it anywhere, but you have to go in order. V to E to N to U. Or the other way, V to E to N to U. It has to be in that order or you're gonna get the wrong answers, okay? So again, I'm looking for this missing side. That really means I'm looking for the missing side of a right triangle. I found out the missing side was 10, but I want to determine the perimeter of the rhombus. All the sides are 10. So all 4 sides times 10, you get 40, all right? Underneath, here we go. The vertices of a square have these coordinates. Again, I just graphed ahead of time just to save us some time. It says determine the perimeter of the square, right? RSTV. So again, I plotted, here I go. I cannot count the boxes on any of these sides because they are not vertical or horizontal on the coordinate plane, right? They're on a diagonal. So when that happens, the only way we have learned to find the missing side of any shape is by using Pythagorean theorem. And I can only use Pythagorean theorem on a right triangle. So I knew that I had to create a right triangle around one of these missing sides. I could have done it on all of them, but what do you know about all the sides of a square? All 4 sides are equal. They're all congruent. So I'm going to use the same process I used up top. If I find the missing length of one side, I can just multiply it by 4 to get all the perimeter, right? All 4 sides. All right, so down here, I can see that my side lengths are 2 and 4. I know that across from the right angle is the hypotenuse, the missing side that I'm looking for, all right, which would be that VT in my case. So here we go, 2 and 4 are my A and B. 2 squared plus 4 squared equals C squared. I'm going to make this side C then. 2 squared is 4, right? 2 times 2 is 4. 4 times 4 is 16. That equals my C squared. When I add those together, I get 20 equals C squared. In order for me to get rid of squaring, I have to square root. So that gets rid of the little 2. This is not a perfect square. Nowhere does it say it around. So the square root of 20 is C. So if this side is the square root of 20, that means all 4 sides are going to be the square root of 20. So now is my final step. If I want to find the perimeter, I'm going to just do 4 times the square root of 20, which will literally just be 4 rad 20, 4 radical 20, for the square root of 20. All right, that's 3 different ways to say this answer. It does not say to round. You cannot type this in. You have to write it like this. All right, next page. If we look up top, let's do one more, and then you're going to practice some as well. So it says the endpoints of one side of a regular polygon are -6, 8, and 2, 3. Again, determine the perimeter. Well, what do I know about a polygon? It has 5 equal sides. All 5 sides are equal. So that means I want to add all 5 sides together to find the perimeter. So right now, I'm going to find the length of just one side because these coordinates, when I connect them, represent one side. And then I can use the same process I used on the last page. If I find one side, I just multiply it by 5 because all 5 sides are the same. So here we go. If I want to find the missing side of anything, we've only learned to do that using Pythagorean theorem. Pythagorean theorem is a squared plus b squared equals c squared. I can only use Pythagorean theorem on a right triangle. Right now I don't see a right triangle, so I'm going to create one. I can either go down and over, or I can go up and over. So I can make a right triangle down here, that's what I'm saying, or I can make a triangle up top. It doesn't matter, it's going to be the same lengths. So when I count the boxes, I get 5 and 8. Here's my right angle. Boom, right across from the right angle is my hypotenuse. This would be my C, that's what I'm looking for. So 5 and 8, here we go. 5 squared plus 8 squared equals C squared. 5 squared is 25. 8 squared is 64. That equals C squared. When I add 25 and 64, I get 89. If I want to get rid of squaring, I have to square root. That gets rid of the exponent of 2. So again, the square root of 89 is not nice. It doesn't say anywhere, round to the nearest anything. All right, so I have to leave it in simplest radical form. This is how I have to leave my answer. But again, you want to reread that question. I want to determine the perimeter of the pentagon. That means I want to add all the sides. This is just the length of one side. It's the square root of 89. But there's 5 equal sides. So again, last step, if I want to find the perimeter, I would do 5 times the square root of 89, right, for all 5 sides. And again, I would just get 5 times the square root of 89, or 5 rad 89, 5 radical 89. All right, this would be my final answer. Underneath, in the diagram of trapezoid ABCD below, I know that AB is parallel to DC. I mark those with arrows. AB is parallel to DC. I'm going to mark that. AD, that line segment, is congruent to BC, that line segment. So let's mark that as well. We mark those out with dashes or those tick marks. The measure of angle A, 4x plus 20, here it is. Measure of angle C, 3x minus 15, here it is. What is the measure of angle D? All right, here we go. This ain't just some regular trapezoid anymore. When I have one pair of opposite sides being congruent, this is now an isosceles trapezoid. Let's write that down. Isosceles trapezoid. So just like in an isosceles triangle, I know that my base angles are equal. So I have base angles at the bottom, and you don't have to do this, but if I flipped my paper upside down, I also have base angles again, right at the top, the bottom. It's however you're seeing it, okay? I have two pairs of base angles. So let me turn it back to where we started here. So I can fill in on the side here, if this is 3x minus 15, this is also 3x minus 15. If that's 4x plus 20, this is going to be 4x plus 20. Here we go. How many degrees are inside any four-sided shape? You guys are crushing this. 360 degrees. All right, that's going to be my total number. So I'm going to add up all four angles and let it equal 360 and then solve. All right, on the side. Just to save some time here, 4x plus 3x plus 4x plus 3x. When I add all my x's together, I get 14x. Positive 20 minus 15 plus 20 minus 15. When I combine all of those numbers together, I get a positive 10. And that whole thing is going to equal 360 degrees because all four angles make that 360. And then I just solve like I would any other equation. I'm going to subtract 10 to the opposite side. If I go to the opposite side, I have to use the opposite operation. Instead of adding, I'm subtracting. I have 14x equals 350. Again, instead of multiplying, the opposite of multiplying is dividing. So I'm going to divide 14 out on both sides. So that means x equals 25. But slow your roll. 25 isn't going to be the final answer. You have to reread the question. That's why I always underline it. It says, what's the measure of angle D? Well, angle D was 3 times x minus 15. So now I can just plug that in. Angle D is 3 times x minus 15. Well, we just said that x was 25. So when you type this into your calculator, you end up getting 60. So I know that angle D was 60 degrees. All right, you guys are going to try that last one on your own. As soon as you are done, check back in the video to see if you got it correct. All right, and here was our answer for the last question. It told me that it was an isosceles trapezoid. Again, just like isosceles triangles, the two non-parallel sides are congruent. Okay, so if these are the lines that are parallel, the top and the bottom, that means these are going to be the legs that are congruent. Another word for congruent is equal. So that means 2x plus 5 equals 3x plus 2, 3x plus 2. All right, so if I'm solving for x, this is how I'm going to do it because these sides are equal. So when you solve through, showing all your work, x equals 3, double check, find the value of x. I did, so I am done. All right, if you need to go back and rewatch anything, please do that. If we look at the last page here, that's the independent practice. All right, make sure that you guys are marking up these diagrams on the side, okay, so that you can solve these questions. If you are not showing all of your work, you will not earn full credit, all right? We're trying to set you up for success. You need to show all work on the region, so you got to show all work for us in class. All right, once it's done, upload it onto Canvas.